This Getting Ready 17 is an extremely long homework, but it's a really good review for your upcoming assessment. So please take the time and go through each and every problem. So the first set here, we are just multiplying binomials. So when we multiply binomial by binomial, what we're really saying is use the FOIL method. Okay. So first times first, 21x squared, outers, negative 15x, inners, negative 28x, and last, positive 20. Combine the like terms, so we have 21x squared minus 43x plus 20. Number 2, first, 9x times x is 9x squared, outers, 54x, inners, 2x, and last, positive 12. Combining like terms, we have 9x squared plus 56x plus 12. And number 3, first, 12x squared, outers, 44x, inners, negative 9x, and last, negative 33. We have like terms in the middle, so 12x squared plus 35x minus 33. Now these next three, this row of problems all have something in common. If you recognize it, that would speed the process up. You might actually skip the foiling and jump right to your answer, but that's not necessary. What they have in common is each one, the two binomials look alike with the exception that we have one positive and one negative in the parentheses. Okay, so that will result in binomials as your answers, difference of two squares to be more precise. So number 4, if we FOIL this, first 49x squared, outers negative 21x, inners positive 21x, and last negative 9. And again, because this will be a difference of two squares, these two middle terms, negative 21x and positive 21x, they're canceled. So we just result in 49x squared minus 9. Number 5, firsts, 9x squared, outers, 30x, inners, negative 30x, and last, negative 100. Middle terms cancel, 9x squared minus 100. Number 6, first, 121x squared, outers, minus 55x, inners, plus 55x, and last, negative 25. So middle terms cancel, 121x squared minus 25. And again, each of those three answers, the binomials, are what we call the difference of two squares. Number 7, 8, 9, they also have something in common. Rather than being written as two binomials multiplied, they're written as a single binomial squared. Okay? In order to FOIL this, though, we should rewrite them as the two separate binomials. So first times first, we get 16x squared, outers, 20x, inners, another 20x, and last, 25. So combining like terms in the middle, we get 16x squared plus 40x plus 25. Number 8, we'll rewrite as x plus 9 times another x plus 9. In FOILing, we get x squared plus 9x plus another 9x plus 81. Combine the two 9x's we see, so x squared plus 18x plus 81. And number 9, we'll rewrite as 10x minus 7 times another 10x minus 7. To FOIL that, 10x times 10x, 100x squared. The outers, negative 70x. The inners, another negative 70x. And the last, positive 49. Combine the two negative 70x's, so 100x squared minus 140x plus 49. So what do we notice then about the like terms, the two in the middle, the OI part of FOIL, in each of these three problems that was different from the previous 6? And that was that the outers and the inners resulted in the same product. So when we combine our like terms, rather than canceling like the three problems at 4, 5, and 6, we ended up with double that amount. So we had a 20x and a 20x made 40x. We had 9x and 9x made 18x. We had negative 70 and negative 70, negative 140x. So you write that in your own words, but when we have a binomial squared, that middle term is really two of the same terms combined. All right, now we're going to look at factored forms of quadratic equations and identify 4 things: the vertex, the x-intercept or seps, the y-intercept, and whether or not there is a vertical stretch, and if so, tell what that number is, that factor. So when we are in factored form, some of these are easier than others. Okay, the two that are very easy to see are the x-intercepts and the vertical stretch. Okay, so we'll do those first. When you're in factored form, the x-intercepts are whatever numbers would make each of these factors equal 0. Now, you probably aren't going to show your work for this, but what I mean is what makes x minus 2 equal 0? Well, if we add 2 to both sides, we know that's 2. And what would make x plus 6 equal 0? We subtract 6 on both sides and find out that's negative 6. So our x-intercepts are 2 and negative 6. Now most of you will just try to remember that you switch the signs. Since it's x minus 2, that intercept is positive 2, and x plus 6 results in negative 6. However, if those factors are a little more complex, if there's a coefficient in front of one or both of these x's, then you do need to come over here and work them out. Work out what would make that whole factor equal to 0. For the vertical stretch, we just look at the a value in front, so it's 4. It has a vertical stretch by a factor of 4, which means it got 4 times as steep. Now, the y-intercept can be, it can be kind of quick, but it's not just staring at us in the problem. What we need to multiply is the two factors, the ends of the two factors, the constants, so negative 2 times 6, and then also multiply that by any a that might be out in front, any vertical stretch. So negative 2 times 6 is negative 12. Multiply that by 4, that y-intercept is negative 48. The vertex is the one, well, it's still pretty quick, I guess, but we know that a vertex is exactly between, it occurs at an x value exactly halfway between the two x-intercepts. So to find my vertex, I need to average the x-intercepts. So that means 2 plus negative 6 divided by 2. So 2 and negative 6 is negative 4. Divide that by 2, we have negative 2. That is the x value of the vertex. Now, that was quick. Here's probably the longest process you would need to do to answer any of these in factored form, and that's to find the y-coordinate of the vertex. Once you have the x-coordinate, you need to substitute that in and find the y-coordinate. So to get y, I'm really doing f of that x-coordinate I found. So I'm going to replace everything in that formula, every x, with a negative 2. So that's 4 times negative 4 times positive 4. So that's negative 64. So that one will be tough to graph. We're going to have to come up with another scale if we ever wanted to graph that one. We wouldn't want to count by ones. But that is probably the longest process out of answering these 4 questions, is to find this y value. Okay, that's the most work. And please, show me your work. Since I'm providing you with all the answers, I can't have you just copying those down and turning that in without understanding the process. Okay, number 12. Again, we're going to jump on our x-intercepts and our vertical stretch very quickly and easily. Since there's no coefficients in front of either of these x's, I can just say my x-intercepts are the opposite of this factor, so -2, and the opposite of this one, +6. The vertical stretch is, well, we can put -3. It would also be, I guess, okay if you just put a 3 there. The negative sign really makes the parabola reflect over the x-axis. It's not actually stretching it in any way. But -3 or 3. All right, so our y-intercept was not terribly difficult. Our y-intercept, we multiplied the a times each of these constants. So -3 times 2 is -6, times another -6 is 36. For our vertex, we don't have too hard a time coming up with the x-coordinate. That's average your 2 x-intercepts. So that's 4/2 or 2. But then to get the y-coordinate, I need to substitute that 2 back into the formula. So -3 times 2 plus 2 times the quantity 2 minus 6. So that's -3 times 4 times -4. So -3 times 4 is -12, times -4 is +48. So the coordinates of my vertex are 2, 48. Factored form again, no coefficients for the x's, so I can say my x-intercepts are -5 and -7. There is no vertical stretch because there's no coefficient in front or following the equal sign. All right, for the y-intercept, again, there's nothing to multiply out here, so just 5 times 7 is 35. Vertex, I need to average the 2 intercepts, -5 plus -7 divided by 2. So that's -12/2 or -6. I know the x-coordinate is -6. Let's substitute that in. Y will be -6 plus 5 times -6 plus 7. So -1 times +1 is -1. Number 14. Again, no coefficients. This is working out nicely for us for intercepts. So intercept here would be 7. Now, this one also tells me the intercept is 7. Well, you can't hit an x value of 7 twice. So that means we only have one x-intercept in this problem. And what that means to us, the only way a parabola can have only one x-intercept is if the vertex is on the x-axis. Okay, we'll come back to that when we do vertex in a moment. For vertical stretch, we take the coefficient in the front. For y-intercept, we multiply that coefficient times each of these constants. So 1/2 times -7 times -7. Okay, so 1/2 times -7 times -7. Now -7 is 49. Half of that is 24.5, or 49 halves. The vertex, now remember, it only has one x-intercept. So if you have in your mind, I need to average the x-intercepts, there's only one. So the vertex also occurs at that x-intercept, so the x-coordinate is 7. So when I substitute that into both parentheses, what happens? I get 1/2 times 0 times 0, which is 0. And that should be kind of obvious after you think about it. If the x-intercept, there's only one, and it's on the x-axis, that means that vertex has to be on the x-axis, so it has to have a y-coordinate of 0. All right, 15. Our x-intercepts are 8 and -4. Our vertical stretch, you could either tell me it's -1/2 or the 1/2. The negative doesn't actually stretch it. The y-intercept, multiply -1/2 times -8, that's +4, times another +4 is 16. For the vertex, we are going to average 8 and -4. So 8 and -4 is 4. Divide that by 2. Our x value is 2. Substitute that into the equation. So -1/2 times 2 minus 8 times 2 plus 4. Or -1/2 times -6 times 6. So that's -1/2 times -36. So 18. Number 16, our x-intercepts, quickly 25 and 9. Our vertical stretch is 3/5, so it got wider. The y-intercept, I'll multiply 3/5 times -25 times -9. Now let's go over here on the side to do that. 3/5 times -25 times -9. So that's 3/5 times, now when I multiply these two negative numbers, it turns positive, and 9/25 makes 225. Now since I'm multiplying that by a fraction, I think of it as 225 over 1. So 3 times 225 is 675 over 5. Well, that does divide nicely. That is 135. So my y-intercept is 135. To get the vertex, I will need to average the two x-intercepts, 25 and 9. So 25 plus 9 is 34. Divide that by 2 is 17. So the coordinates of the vertex, 17, and we have to go find our y. So the y will equal 3/5 times 17 minus 25 times 17 minus 9. That's 3/5 of -8 times +8. Well, -8 times +8 is -64. Since we're multiplying that by a fraction, we think of it as -64 over 1. So that would be negative, let's see, 3 times 64 is -192 over 5. Now, I like that fraction just as is. It would be a nice neat decimal. If you prefer, you could divide that and it would be -38.4. Number 17, x-intercepts, 3 and -3. Vertical stretch, 3/4, meaning it got wider. Y-intercept, we're multiplying 3/4 times -3 times 3. So that's 3/4 times -9, which is -27 over 4, or -6.75. So y-intercept, -6 3/4. The vertex, I need to know the average of 3 and -3. So 3 and -3 is 0, divided by 2 is 0. So the x-coordinate for my vertex is 0. We'll substitute that in to find the y value. 3/4 times 0 minus 3 times 0 plus 3. Well, that would be 3/4 times -3 times +3. Now, if you're paying attention, that matches a problem we just did a moment ago. So that is at -6.75. Now, that's okay. It's nothing special. It just means the vertex occurs on the y-axis. So the y-intercept and the vertex are the same point. Number 18, our intercepts are 5 and -5. Our vertical stretch, now there is a different coefficient out here. There's a -1, but that's not really stretching it at all. So technically, your answer here should be there's none. If you wrote -1, I wouldn't be really upset about that. But know that a negative sign, all that does is reflect the graph. It turns it upside down, it reflects it over the x-axis. It does not actually stretch it. Y-intercept, I would do -1 times -5 times 5. So that's +5 times 5, or 25 is the y-intercept. The vertex would be the average of 5 and -5. And if this is feeling at all familiar to you, if it seems like the last problem, there is a big similarity here. And that is that when we got the 0 for the x-coordinate of the vertex, that's telling me that it's on the y-axis. So it has to hit it at 25, all right? If we did take the time to substitute that 0 in there, 0 minus 5 times 0 plus 5, that's negative times -5 times 5. So that's +5 times 5, there's your 25. 19. Our intercepts are -10, and we would see -10 again. We don't write it twice, so we know there's only one x-intercept. It's at -10. The vertical stretch is 2/3, so it got wider. The y-intercept is 2/3 times 10 times 10. Now, this 2/3 is a repeating decimal, so we are going to get an improper fraction or a mixed number here. We do not want to round that. So 10 times 10 is 100. So 2/3 times 100 is 200 over 3. I like that answer. If you don't, you could also call that, what is that, 66 and 2/3? But I'm going to choose to just keep that 200/3. Do not round it, though. The vertex. The vertex, we would say, is the average of the x-intercepts, but we only have one. So the vertex has to also happen at the x-intercept. And for that to happen, that means it has to be on the x-axis, so that y-coordinate is 0. Again, if you did not catch on to that, you would work it out as so. You would put the -10 into both parentheses. So I would have 2/3 times 0 times 0, and that is 0. Whew. All right, so we're done looking at the factored form for now. We are, however, going to go through the same set of requirements, vertex, both intercepts, and a vertical stretch, with vertex form now. Now, each of these forms that we've studied have their benefits and their, I guess, drawbacks. For the factored form, it was very easy for us to identify the x-intercept and the vertical stretch. In the vertex form, maybe obvious because of its name, the easy things to identify will be the vertex and, again, the vertical stretch. All right, your intercepts will take a little more work. So for the vertex, remember, vertex form is a times quantity x minus h squared plus k. And in that case, the vertex is the coordinates h comma k. So in this problem at number 20, that h and k would be -2, -4. It's always opposite of the sign that we see in the parentheses, and then keep the sign for the k value. The vertical stretch is also very obvious in these equations because it would have to be a number in front of that. It would have to be the a value, so we don't have any. The x-intercepts and y-intercept are not going to be quick. We do have to do work. So remember, for an x-intercept, that's where y equals 0. So for x-intercepts, and please show me your work, for the x-intercepts, I will substitute 0 for y. Now, how did we solve this equation when it was in that vertex form? We said the quickest way would be to get rid of the k, add that to both sides or subtract it if it's positive. Once you have the squared binomial alone on this side, then you can take the square root of both sides. The one trick thing to remember here, though, is there are always two square roots of any positive number, both a positive and a negative one. So plus and minus 2 would equal x plus 2. So that is really giving us two equations. This means we would say 2 is x plus 2, but also negative 2 is x plus 2. Subtract 2 on both sides, we get 0. Subtract 2 on both sides, we get negative 4. So 0 and negative 4. Yes, that is the simplest way to get the x-intercept. It does require work. The y-intercept, remember with y-intercept, we are looking for when the x is 0. So still a little bit of work, not as much as the last one though. So we substitute 0 for x. So that's 2 squared minus 4. 4 minus 4 is 0. So the y-intercept is 0. All right, number 21. Again, the quick and easy ones, I can identify vertex and vertical stretch without much effort. The vertex would be opposite sign, negative 6, and then positive 3. The vertical stretch, if you wrote negative 3, that's fine, or 3. The x-intercepts, again, that is where the y is equal to 0. So 0 equals negative 3 times x plus 6 squared plus 3. So we need to first isolate this binomial squared. So we'll subtract 3 on both sides. Then we will divide both sides by negative 3. So we get 1 is equal to x plus 6 squared. At this point, you can take the square root of both sides, remembering that that is really two answers. Positive and negative 1 is equal to x plus 6. So the two equations that I will solve are 1 is equal to x plus 6, and negative 1 is equal to x plus 6. Subtract 6 on both sides, we have negative 5. Subtract 6 on both sides, negative 7. So x-intercepts negative 5 and negative 7. The y-intercept is where x is equal to 0. So for the y-intercept, I will substitute 0 for x. So the y value is negative 3 times 6 squared plus 3, or negative 3 times 36 plus 3. Well, negative 3 times 36 is negative 108. You add 3 to that, we're at negative 105. Our vertex quickly is 1, negative 8. Our vertical stretch is 2. All right, for x-intercepts, we will substitute 0 for y. To solve this, isolate the squared binomial, so add 8 to both sides. 8 is equal to 2 times the quantity x minus 1 squared. Divide both sides by 2, so that 4 is equal to x minus 1 quantity squared. Take the square root of both sides, remembering that every positive number has two square roots. We have positive and negative 2 is equal to x minus 1. Split it into two small equations. 2 equals x minus 1. Negative 2 equals x minus 1. So when we add 1 to both sides, we have 3 and -1. So 3 and -1. Y-intercept is when we substitute 0 for x. So for our y-intercept, y is equal to 2 times 0 minus 1 squared minus 8. So the y value will be 2 times -1 quantity squared. Don't lose the parentheses at this step. You need, when you square a negative number, you need those parentheses. So that's 2 times, that turns into +1 minus 8, or 2 minus 8, so that's -6. All right, once again, vertex, quick and easy, -2, -64. Vertical stretch is a 4. For x-intercept, we will substitute 0 for y. Okay. So isolate the squared binomial by adding 64. So 64 is equal to 4 times quantity x plus 2 squared. Divide both sides by 4. So 16 is x plus 2 squared. Take the square root of both sides. So square root of 16 is both positive and -4. Square root of the quantity x plus 2 squared is x plus 2. And then make your two smaller equations to say 4 is equal to x plus 2 and -4 is equal to x plus 2. Subtracting 2 on each side, we have 2 for an x-intercept and -6 for the other x-intercept. So 2 and -6. For our y-intercept, we are going to substitute 0 for x. So y is equal to 4 times 0 plus 2, quantity squared, minus 64. That becomes 4 times 2 squared minus 64. 2 squared is 4, so that's 4 times 4 minus 64, or 16 minus 64, which is -48. Vertex, 248. Vertical stretch, 3 or -3. X-intercepts, we'll need to substitute 0 for the y value. Isolate the squared binomial, so subtract 48 on both sides. We have -48 equal to -3 times x minus 2 squared. Divide both sides by -3. So positive 16 is quantity x minus 2 squared. Take the square root of both sides. We have positive and -4 equal to the quantity x minus 2 quantity squared. Whoops, I'm sorry. Positive -4 is equal to x minus 2. I apologize. Once we take the square root, the parentheses and the exponent are gone. Split into two small equations. 4 is equal to x minus 2, and -4 is equal to x minus 2. Add 2 to both sides. First intercept is 6. Add 2 to both sides. Next intercept is -2. So 6 and -2. And our y-intercept. Our y-intercept we locate by substituting 0 for x. So -3 times the quantity 0 minus 2, quantity squared, plus 48. That is -3 times -2 squared. Again, don't lose those parentheses. -2 squared is positive 4. -3 times 4 is -12. When we add that to 48, it's 36, positive 36. Okay, number 25. We have no vertical stretch, and our vertex is at -6, -1. Okay, again, x-intercepts come from substituting 0 for y. So I will add this 1 to both sides. Take the square root of both sides. So positive and negative 1 is equal to x plus 6. Make your two small equations. 1 is equal to x plus 6, and negative 1 is equal to x plus 6. Subtract 6 on both sides. Our first intercept's negative 5. Subtract 6 on both sides. Our other one is negative 7. And the y-intercept. The y-intercept, we substitute 0 for x. So y-intercept, 0 plus 6 squared minus 1. That is 6 squared minus 1, or 36 minus 1. So our y-intercept is 35. Now, did we notice that the parabolas in numbers 11 to 13 are the same as the ones in 23 to 25? If you look back at them, what we mean by having the same parabolas is we had all the same answers. The vertex, the x and y intercepts, the vertical stretch were the same answers, even though the equations look totally different. So, if we are to prove that, we have the factored form, like this is from number 11, and this vertex form, this is from number 23. We are going to show that they're actually equivalent. Now that means manipulating the equations until they look alike. Now, you could try to turn the factored form into vertex or the vertex into factored form, but those both seem like more work to me than if you just turn both of them into standard form. Standard form, remember, is ax squared plus bx plus c. So in order to turn this left-hand side into standard form, first I'm going to FOIL x times x, x squared, x times 6, 6x, negative 2 times x, and negative 2 times 6, negative 12. When I combine the like terms here in the middle, that's x squared plus 4x minus 12. However, I still have this 4 sitting out front, so that was there all along, and I would now need to distribute that into the trinomial. So that becomes 4x squared plus 16x minus 48. Now, we're hoping for the same result on the right-hand side. Now, remember, with this in vertex form, this x plus 2 quantity squared should be split into, or rewritten as x plus 2 times x plus 2. And then don't forget about the minus 64 for last. So we still have a FOIL problem to do. X times x, x squared. There's 2x, another 2x, and a 4. When I combine like terms, that's x squared plus 4x plus 4. But remember, there's still a 4 in front of that and a minus 64 behind it. So let's go ahead and distribute the 4. That's 4x squared plus 16x plus 16. And then we have a minus 64. When I do my subtracting there at the end, 16 minus 64, I get negative 48. So the result when you turn them both into standard form is they are exactly the same equation. Got 2 more to do like that. Okay. So again, on the left-hand side, we will first FOIL and then distribute the negative 3. An alternative would be you could distribute the negative 3 into one of those binomials. It doesn't even have to be the one it's right next to. Either one of them, and then FOIL that resulting binomial times the remaining one. I find that we get less mistakes if we FOIL first. So here's x squared minus 6x plus 2x minus 12, which simplifies to x squared minus 4x minus 12. But don't forget, there's a negative 3 there. Distributing that, we have negative 3x squared plus 12x plus 36. We're hoping to find the same result on the right. So I first rewrite it with x minus 2 times x minus 2, and then start FOILing. x squared minus 2x twice, both the outers and the inners result in minus 2x, and then plus 4. When I simplify that, I have x squared minus 4x plus 4. And then let's bring back the negative 3 in front and the plus 48 behind. So we distribute the negative 3x squared plus 12x minus 12. When I add 48 to the negative 12, I get a positive 36, and my two equations do match exactly. And the last one here will be the shortest of these three final questions because there's no a term in the front. Okay, there was no vertical stretch. So this time on the left-hand side, all we need to do is FOIL. So x squared plus 7x plus 5x plus 35. Combining our like terms, x squared plus 12x plus 35. And we're hoping for that same result on the right. So on the right here, I'll rewrite it as x plus 6 times x plus 6 minus 1. As I FOIL, first is x squared, outers 6x, inners 6x, and last positive 36. And don't lose your minus 1. I can combine all the like terms I have in one step. So x squared plus 12x plus 35. And yes, those are matching.